Hey guys, today we will be doing this problem on cache and main memory organization. So given a 128-bit data CPU with 32-bit logical addresses, that's for a byte addressable processor, um, let's dive into how the memory would be organized. So first, 128-bit data is 128-bit words, which is 16 bytes. And from our graphic here, we have two-way lower order interleaving. So that means our block size is 16 bytes times two words, which is 32 bytes. So for each way of interleaving, we need one transceiver. So we have two-way interleaving, we need two transceivers. And each transceiver needs to take in a 128-bit bus input, so they're of size 128-bit. But the memory module here is a bus that turns 128-bit into another 128-bit and another 128-bit, so that's 256. So it goes from 256 bits to convert from the CPU bus of 128 bits. Next, let's go into the address. Let's go into the addresses. So there's 16 bank enables, so that means we need A3 to A0 to select a bank. But we also have we have two words at any time for our interleaving, so we also need to select between this transceiver or this transceiver, meaning we have A4 be responsible for word select, and then we have our byte offset for our bank enables from A3 through 0. So the address bit A4 and its two combinations, either A4 equals 1 or A4 equals 0, go here. So now our address bits that we input are from A31 through 5. And that's 27 bits. So that means we have this is 2 to the 10 bits, or 2 to the 20, m is 20, k is 10, and then so that means we have 2 to the 7, uh, 2 to the 7 MB in a single byte wide bank. So we have 128 MB in each byte wide bank um, in main memory. So next, let's see what our block size is. So we already said that that was two words because that's dependent on the lower order interleaving, and that's 32 bytes. And then let's look at our tagrams. So they tell us we have 7 tagrams, blocks 0 through 6, so 7 tagrams. So that means our degree of set associativity is actually 7 blocks per set. Now, they tell us our tagrams are 512 deep, and 2 words per block. So that means we have 512 blocks times 2 words at 16 bytes per block. So if we multiply that all out, we should get the size of one tagram because they tell us the depth of our tagram. So that's 512 times 2, which is 1K, times 16 bytes is 16 kilobytes in each tagram. So 16 kilobytes in each segregation of tagram. So now our total cache size is the size of our tagrams times how many tagrams we have. So we already said that that was 16 KB times 7, which is our degree of set associativity, which is 112. So we have a total of 112 kilobytes of our total cache size. Now our address space just depends on how many bits we have in our logical addresses. So that is 32-bit logical addresses, which is and byte addressable processor, so 32 bits times byte wide, so that's 2 to the 30 is 1 gigabyte times 2 to the 2 equals 4 gigabytes is our total address space. Now let's try and fill in some of our tagrams. So if we have 512 blocks, that means we also have 512 sets in our cache. So that means we have 2 to the 9 bits to index these 512 sets. So that means our set field will be actually 9-bit set. And we know that we start from A5 because the rest are for interleaving or bank enable. So from A5 plus 9 bits, we also have to count the last bit also. So plus 8 is 813 through 5 as our address bits. Then the rest of our bits are our data bits, and those go from 831 through wherever we left off, 14. And how many bits is that? That's, well, we have 2 here, we have 6 here, and we have 10 in the middle. So that's 18 bits plus a valid bit. So that's a 19, that's a 19-bit line data input. And then the size of our comparator, so is our data in the same as our data out? Well, that's 19 bits, so we have a 19-bit comparator. And our tagrams are 512 number of sets or blocks by 19 bits. Now, for our data cache RAM, this is our set field concat with word field. And so that is wherever our set field starts, so that's from 13, but we also have one word select, so that's 4. And then the size of this, so that's a 10-bit input, so 2 to the 10 is 1 KB, so the size of one byte wide bank is only 1 KB in our cache. So now we've done all of that. It should be pretty easy to now divide our address. So our last 4 bits are for bank enable, so these are our, you can call it byte offset. Then we have 1 bit for word select. And then our set field is the same as the depth of our tagrams, so that goes all the way to 813, so this is 9-bit set field. And then the remaining 831 through 814 is just our tag field. And that should about solve it, giving an idea of cache and main memory and how they're kind of connected. Thank you.